everybody, True Thick Dong here. This video is dedicated to It's a Banans, who has requested that I make a video on logic for his generous Patreon donation, and I appreciate it a lot, man. It goes a very long way. Now, recently on my Discord, there's been a lot of conversation about logic and a lot of people trying to get their heads around basic concepts, and seeing there are a lot of Shane Killian fans on my Discord, people are often inquiring about a certain statement Shane made in his series on the non-aggression principle, which was this.
Here's the thing about logic. It's completely objective. There's no my logic or your logic. There's just logic.
So this idea of there's no your logic or my logic, there's just logic. Now, is this true? Well, it's sort of complicated. Some people might have a simple understanding of logic as to think it's synonymous with proper or valid reasoning, and therefore Shane's statement is to say there is only one true way to reason, and that you cannot reason in such a way that is valid for you and not for me. But is this really so? Well, this could be true, but we are no longer talking about logic, as logic isn't just the same as reasoning. Many would say logic is to reasoning as mathematics is to, say, carpentry. The two aren't synonymous, but mathematics lends the carpenter the tools in which to understand his craft. So, logic isn't reasoning in itself, but it encompasses various proof systems that can be used to test the validity of a proposition. And we will put forward a proper definition of logic in a moment. Now, would it make sense to take Shane's statement to mean there is only one correct proof system? Does this make sense? Well, the answer is a blatant no. The study of logic is comprised of learning various proof systems. Often these are called logics. However, various logics have their own theorems that can provide multiple proof systems in themselves, and so forth. Now, some of these systems are contradictory to each other and make competing suppositions about the nature of truth, while some are simply expansions of each other which seek to encapsulate something other logics can't, without saying they are necessarily wrong, just that they are insufficient. The first type of logic someone will be introduced to typically is classical logic, also known as first-order logic with identity. Often, after having an understanding of this one will go on to learn, say, predicate logic, which seeks to expand classical logic to test the validity of certain propositions that first-order logic is insufficient for. And then, upon learning predicate logic, one can go on to learn a whole world of different logics. There are non-classical logics that, given the name, are alternatives to classical logics. Examples like modal, tense, intuitionist, relevance, many-valued, fuzz, and free logics. In addition, there is mathematical logic and meta-theory, where one can learn compactness theorems, the undecidability of first-order logics, Gödel's incompleteness theorems, while there are also philosophical logics, e.g. monism versus pluralism, normativity of logic, or analysis of logical consequence, and so on. You get the idea. Logic is very complicated. And it should also be said, a lot of libertarians online will talk about logic and their use of it in their arguments, but then not express any of their arguments in actual logic. They won't use any actual proof systems to test the validity of their arguments. They just equate logic with reason and give an argument consisting of premises with a conclusion. In fact, I watched a video by Esoteric Entity where he tries to use, quote, logic to demonstrate natural law after he had attempted to correct my understanding of logic in a response to my video on the non-aggression principle.
If you say we're not making an argument, then I'm not even sure that you understand what our argument is.
In which he thinks practicing logic is to simply state the law of non-contradiction without actually demonstrating it using even the most basic of logical tools such as truth tables, something we will look into. But he essentially claims that there are no contradictions in nature because inconsistencies can't be applied consistently, which is entirely circular because you have just assumed the law of non-contradiction in your effort to demonstrate it. And then he just says that firstly, because we delegate different rights and responsibilities to the government than we do to citizens, we are contradicting ourselves, and all the other stock standard ANCAP arguments as, he just says this is an exercise of logic. Now maybe it's an exercise of reasoning, whether you think it's sound or not, as, making an argument expressed verbally with premises and a conclusion is fine for just general truth-seeking, reasoning, and etc., but it isn't fine for the purpose of understanding actual logic, which is the reason for this video. But, I am dealing with a guy that, in trying to argue about formal logic with me, references the dictionary instead of any actual logic literature. But to continue, I'm not here to quote debunk his arguments or whatnot. I'm here to again explain the basics of logic according to what any layman with a textbook can muster. So let's try and get a comprehensive definition of logic. First and foremost, logic is concerned with propositions and their components. A proposition simply being a statement that is true or false, and through logic, we seek to discover laws governing the relationships between the truth or falsity of different propositions. Hence, the task of the logician is to develop a framework in which they can give a detailed representation of propositions and their components and identify the general laws governing the ways in which truth distributes itself across them. That is to say, logic is not concerned with discovering truth. This is the task of the sciences. Logic is instead for the purpose of discovering the laws of truth. To quote Gottlob Frege, the famous philosopher, "Just as beautiful points the way for aesthetics and good for ethics, so do words like true for logic. All sciences have truth as their goal, but logic is also concerned with it in quite a different way. Logic has much the same relation to truth as physics has to weight or heat. To discover truths is the task of all sciences. It falls to logic to discern the laws of truth." End quote. Now let's focus on propositions, what all of philosophy is concerned with. The Aristotelian understanding of a proposition is that a proposition is a claim about how things are. It represents the world as being some way, and if the world is that way, the proposition is true, and if the world is otherwise, the proposition is false. Examples of a proposition would be the earth is round, or the earth is flat, or the sky is blue, or aliens exist. Just claims about reality. Now, it is important to note a non-proposition isn't false. A non-proposition simply says nothing about the world around us. It is incapable of being not only true, but false also. A statement such as close the door or ouch would be examples of non-propositions. Non-truth apt statements that don't add any information to our model of the universe, whether that information is accurate or not. Now secondly, we must spend some time understanding what an argument is, at least what an argument is in philosophy, and I know a lot of people will know what these things are, but it is important this is made clear for when we introduce our first logic. So, when we exercise our reasoning, we do so in all sorts of ways. We speak in ways that aren't standardized, and we introduce propositions in ways that often have to be uncovered. Sometimes they are implicit, and sometimes they are explicit, so for the purpose of understanding the laws of truth that underlie our reasoning, we must introduce a standard form in which any ordinary piece of reasoning can be represented, and this we will call an argument. This standard form is just a sequence of propositions in which the last proposition is the conclusion, the claim we are attempting to establish as true, while the other propositions are called premises, the propositions that make the basis of which we accept the conclusion as true. An argument is typically presented like this: premise 1, premise 2, and then a line signifying the conclusion, and moreover we can sub in propositions into this argument, and as long as each sequence is a claim about the world, as long as each is a truth-apt proposition, this is still an argument, because an argument describes a form. It doesn't have to make sense, it doesn't have to be persuasive, but as long as it is a sequence of propositions consisting of premises intended to justify a conclusion, it's still an argument. However, what is a good argument? Well, a good argument must be such that it is impossible for the premises to be true and the conclusion to be false, and an argument that has this property is said to be necessarily truth-preserving, or NTP for short. Just as the argument you see here is, it is impossible for it to be either raining or sunny, and then for it to be anything other than sunny provided this first premise is true and it isn't raining. Hence, the argument is necessarily truth-preserving. Now, an argument that is NTP is said to be valid, while if it is not NTP, this is to say it is not guaranteed by the form of the argument, something that will make more sense in a moment. So, in this case, it is said to be invalid. And as some of you may realize, a good argument mustn't just be NTP, but it must also be sound, which simply means not only does the conclusion follow from the premises, but the premises must all be true. And as you can tell, this argument here isn't sound. Why must it be either raining or sunny? For instance, couldn't it also be snowing? But anyway, to talk more about necessary truth preservation, something that some might not know is that what ensures that an argument is NTP, at least in classical logic, is not its contents, but its structure. Now this might be confusing to some, but let me explain. If we take this argument, it is either raining or it is sunny, it is not raining, therefore it is sunny, this argument follows a certain form. The propositions are structured in such a way that if any proposition is subbed into any of the premises, as long as the form stays the same, the argument will be NTP. Now, as I touched on before, using English sentences to determine the structure of an argument is not that wise. English sentences have a large degree of interpretation with its propositions delivered in an array of different ways, so for the purpose of this video, we will use letters to represent each proposition. As you get into more advanced logics, you will also use various subscripts and so forth to represent the internal structure of each individual proposition. But for classical first order logic, we won't be doing this. So here you can see that same simple argument. It is either raining or it is sunny. It is not raining, therefore it is sunny. Notated using the first part of the basic language of propositional logic. R vel S, neg R, therefore S. Here R is short for the statement it is raining, while S is short for the statement it is sunny. Why? Well, because S is short for sunny and R is short for raining. These are just variables. It is also common to use the letters P and Q, but as we keep adding more propositions than just two, it is easier to notate using other letters, while also vel, or this arrow symbol, is short for a disjunction, which is a connective between two propositions that states at least one of the propositions is true. It is either raining, it is either sunny, it could be that it is raining and sunny, but it can't be neither. This basically just means or. It is raining or it is sunny. However, this connective means both propositions can be true as well, not just one, and of course, in reality, it can't be raining and sunny. This is not what the arguer meant, so we will introduce a new, rarer connective called an exclusive disjunction, or XOR, which simply means it is either one or the other, but not both. It is either raining or it is sunny, and not both at the same time, and not neither. The true sense of the word or that was meant in this argument. And so, this connective, just like most other connectives, takes these two basic propositions and connects them to be its own well-formed formula, what is also called a wolf for short. And this term, wolf, is what is used to refer to any basic proposition, including compound propositions, constructed via connectives. And of course, XOR, or the exclusive disjunction, is just one of many connectives. For instance, in the second premise here, this neg, or negation, is a connective that simply means the proposition in front of it is false. You could essentially just read it as not. It is not raining. If we moved it up to this first wolf, we would be saying that it is not raining, nor is it sunny, which would be saying both propositions, that is, it is sunny or it is raining, are false. In fact, for a negated exclusive disjunction to be true, both operands or propositions have to be the same, but in the meantime, we aren't negating this, so here we have expressed this simple argument using the most basic language of propositional logic. Now, for this video, I thought it would be fun to take Shane's argument and express it using propositional logic. Firstly, it should be noted that Shane actually makes a bunch of arguments in this video, and for each point he provides multiple reasons to accept each conclusion, so I'm only going to pick one, and that will be the one regarding self-ownership. Another reason why I'm picking this one is because I've heard this mentioned many times before, including by Esoteric Entity in the video that I mentioned just before. So the general argument goes like this. Shane claims that either one owns themselves or one doesn't own themselves. If one doesn't own themselves, then any action against them is justified. This is false vis-a-vis reductio ad absurdum, and so therefore one does own themselves. Firstly, when it comes to this argument, we can ascribe the proposition that one owns themselves as an S, just for self-ownership, while for the proposition that all actions are justified, we can ascribe an A for all actions. Therefore, we can notate the argument as S vel neg S arrow A, neg A, therefore neg A arrow S. Now some of you might notice this arrow connective. This simply means if the antecedent proposition is true, then the consequent one is also true. Or to put it simply, if X, then Y. And because we are saying if one doesn't own themselves, then all actions are justified, we just use an arrow to notate it. Now, given that we have expressed this argument using the basic language of propositional logic, we actually have a few ways of testing its validity, now that we can see its structure, the first of which being via what is called truth tables. Now, I don't expect someone who is only hearing about logic for the first time to understand this, but I'll explain the general gist of it quickly so you get the idea. So, of course, in logic, it should be noted that every proposition has a truth value. A truth value simply being the attribute assigned to a proposition based on its truth or falsehood, and in Aristotelian logic, every proposition can only have one of the two types of truth values. That is, it can either be true or false. And so with each proposition, we can construct a table in which we list all the possible truth values that propositions might have. For now, let's just use generic propositions rather than the ones Shane gave us. Later, we can sub Shane's in to test its validity. So here you can see we have a row where both P and Q are true, one where only P is true, one where only Q is true, and one where neither are true. Obviously just using T to denote true and F to denote false. But what about a compound proposition? What if we get something like this? Two propositions linked via a connective. This connective being called a conjunction, which simply translates to basic English as and, but is known as caret when it's said in an argument, i.e. P caret Q. But anyway, we can still use truth tables to ascribe the different truth values of a compound proposition based on the truth values of the basic propositions that it is comprised of. For instance, for a conjunction, you can see that when P and Q are both true, its conjunction is also true, while when P is true and Q is false, then its conjunction is also false, and when P is false and Q is true, then its conjunction is false again. And similarly, for when neither P and Q are true, because both P and Q are false, its conjunction is again also false. Now, we could repeat this for each type of connective, but we won't. And also, if you took a test on logic, the truth tables for each connective would be given. They aren't debated in classical first order logic, as it is a long studied and accepted language. So for the purpose of this video, we are just going to refer to the ones given in a basic logic textbook, as you can see them all here. So moreover, if we want to just test a whole argument using truth tables, we just take each premise of the argument to be its own column and go from there. So let's take Shane's argument. Now what we can do is just look over and see what truth value would come out of each possible arrangement of the truthhood of each proposition. So for the first premise, that we either own ourselves or we don't own ourselves, or S vel neg S, we look at the truth table for a disjunction, and we see that if S is true and neg S is false, then S vel neg S must be true. The next row is the same, so we just write true again. When S is false and neg S is true, then S vel neg S must be true, and the next row is the same again, so it must be true also. And we just keep doing this to each premise, and at the end we can look over, and if we have a row where each premise is true, then we have a valid argument. And just on a side note, if every value in the table here was true, then we would have a tautology, which is also known as a rule of logic. In other words, a formula which is always true for every assignment of truth values to its simple components. An example of this would be the law of non-contradiction, and this is actually how you go about proving it or testing it. Now, after one learns truth tables, we can move on to another way to test the validity of an argument that allows one to test much more complex arguments much more quickly. This means of testing an argument is called trees, or a logic tree. Now, I, again, don't expect anyone who has never heard of logic trees to understand this immediately. This takes time to learn, and I'd recommend looking it up if you are interested, but what I'm doing here is this. If this argument is valid, this means it is necessarily truth-preserving, and thus we should be able to negate its conclusion and only find contradictions between it and the other premises. Or to put it simply, if the conclusion follows from the premises, then the opposite of the argument should ensure none of the premises lead onto the conclusion. So here, we negate the conclusion, and then we have various rules similar to the rules given in our truth tables, but slightly different. And we then see if every branch here can be closed off via the emergence of a contradiction. Then we have proven the argument is necessarily truth-preserving. So for this simple argument, we get this, and these crosses here mean that it is perfectly contradictory, and thus the original unnegated argument is valid. Again, we can see here that Shane's argument is valid, so thanks, Shane. Now, for the purpose of this video, I won't explain why each branch emerges or not. I'm just going to point to the rules we have been given, and maybe in the future I will, but for now I'm just going to tell you about it. But if you do want to learn about why the branches, or what are also called lists, or these parts emerge, then check the description. So for now, let's look back at Shane's original statement, and I hate to keep using him as the test dummy for this video, it's probably pretty condescending, but Shane, I like you, and keep up the good work. But anyway, if we look at this statement, there's no logic or my logic, there's just logic. Can we now say that it is true? Well, again, we could say this is true of just general reasoning, but given the logic we have just looked at, what if I try to express the following argument using basic first-order propositional logic? All men are mortal, Socrates is a man, therefore Socrates is mortal. So, firstly, let's assign each proposition a variable as we did beforehand. All men are mortal can be M, Socrates is a man can be S, and Socrates is mortal can be, oh, I don't know, C, because it's our conclusion, I guess. Remember, the variables are just for reference. We could also just make them A, B, C if we want to do, but anyway, here is our assignment, M, S, C. Now, by any of the tests we have just looked at, this argument is clearly invalid. The form of the argument isn't in any way truth-preserving because it's just 3 propositions in a row. It doesn't have any means of ensuring the conclusion follows from the premises like in Shane's argument. However, if we look back at the original argument, we know this is valid. In fact, I picked this argument just because it is always the first example of a valid argument someone will give you in like a philosophy classroom or somewhere, but the reason why it comes out as invalid is because there are limitations to propositional logic, in which classical first-order propositional logic becomes insufficient to test the validity of an argument, and hence, there isn't just logic, and there is a whole world of debate over what logics best encapsulate various propositions and their compounds. But for an argument like all men are mortal, Socrates is a man, and thus Socrates is mortal, our propositional logic falls short to articulate it because these premises have properties, while the other premises we have looked at so far did not. So let's look at each premise to get a clearer picture of what I'm saying. The first premise states that if something has the property of being a man, then it also has the property of being mortal, while the second premise states that Socrates has the first of these properties, so thus the conclusion states that Socrates must also have the other property of being mortal. Now we can introduce a new logic called predicate logic that offers us a way of articulating these properties and enabling us to test the validity of the arguments that have them in their premises. Now, in predicate logic, we introduce lowercase and uppercase letters to symbolize the properties of a proposition, and we call the thing we are talking about the name, for instance Socrates, and we call the property assigned to it the predicate, for instance being mortal. Then we can introduce some quantifiers, as to say, for all x, what we would call a universal quantifier, or for some y, what we would call a existential quantifier, and so now we can represent each premise to look like this. But maybe predicate logic is for another video. I just wanted to explain how there isn't just one logic that encapsulates all of human reasoning. There are many, some of which are competing and contradictory with each other. For instance, if some of you take issue with the fact that the validity of an argument is determined not by its contents but by its structure, then the non-classical logics are maybe for you. And that's just to give an example of where one logic might be insufficient and you might have disagreement with the correct logic to use in various situations, while others are not competing or contradictory but are again simply expanding upon that which another logic is limited on. But anyway guys, I hope this cleared some things up for those who are interested in beginning their journey into studying logic. This is really just the tip of the iceberg, and there are a lot more things to say. I could literally make a whole video on every concept mentioned in this, and there are other basic concepts that I didn't mention, but if you guys are interested, I would highly recommend the textbook Logic, The Laws of Truth by Nicholas J.J. Smith. It's where I learned most of what I know on classical logic, predicate logic, and general model theory, and it's really clearly explained, so definitely go buy that book if you want to learn more. And remember, this video is paid content by ya boy, It's a Banans, the furry degenerate you might see on my Patreon hangouts. He was kind enough to pay me $15 via Patreon, of which the reward is a video suggestion. So thanks again, man, appreciate it. If you want to support the channel, then going over to my Patreon would mean the world to me, even if it's just $1 a month, or alternatively, you can go to my Teespring store and buy some threads. That helps out a lot also, and you know, I have some new designs coming in soon that I didn't just make myself using GIMP, so look forward to that. I have some awesome mugs over there as well, and remember that my social media links are in the description, but yeah, catch you guys later.
can't let go. I only want the best, it's true. I can't believe the things I do for you.